Hi everyone, my name is Tim Marple, and today I'm going to be giving you a basic introduction into statistical computing in RStudio. Now, if you don't have R and RStudio installed on your computer, I recommend you pause the video right now and take the time to download it. The link should be available on the Moodle page provided by Meredith. If you do have it downloaded, let's begin by opening the lesson1.r script that was provided also on the Moodle page. You can do this either by clicking Ctrl-O or navigating to the top and clicking File, Open File. From there, you can navigate to wherever it is that you keep your R scripts. Personally, I keep mine in a folder called R Lessons, but just double click and open it up. You should have it open in the top left area. This is where you keep your scripts. A script is different from the console, which is down here, because it is a collection of commands for R to run at any given time when it is open. You can run a command simply by holding Control and Enter when your cursor is on the appropriate line. If there's nothing on that line, it will not run any command. The console, alternatively, you can type commands directly into. You can copy and paste from up here, but it's much more convenient to store your commands for a later time. So, if you've got your console and your script open, we can begin by exploring what R actually is. In reality, R is actually just a very large supercalculator. It's able to handle complex equations, much more complex than these ones. But if you click Control-Enter on lines 6 through 9, you'll see that it very quickly returns the response to these mathematical equations. It is aware of order of operations, as you can tell with the parentheticals and its acknowledgement of that, and it can even incorporate powers, different other things like that. But R would be very boring if this was all it could do. It actually allows you to go farther and into incorporate your own data, which is something that we're going to be going through today. A very important part of working with R is setting your working directory. You should have all of your files stored on your desktop under a folder called My Working Directory. If you don't have this, including your script and the mydata.csv file in that folder, I recommend you stop the video now and get those in a folder titled My Working Directory. If not, you can highlight this part here where it says TEMAR and change it to the username on your computer. This reads files from this path directory. It'll look in my desktop folder under the username Tim and try to find my working directory. Apparently I don't have one. Now if you didn't set your working directory up or you're having a little bit of difficulty, we can read data differently. If you do have your working directory set up, you can read it in just by clicking Control-Enter on line 25, and it should be it should read right in. Alternatively, we can copy this line, and we can change mydata.csv to a different command called file choose. Take some time to write that out. Now what this does, if you run it, is it gives you a pop-up window where you can navigate through your files and go to wherever it is that you stored mydata.csv. Just open that up, and what you should have now is an object in the top right box. This is your environment. This is where all of the objects in R are going to be stored. You can click on this, and it should show you a data frame that resembles the components of the CSV that I provided you all with. This includes the ID of various student respondents, these are fake data, their age, their height, their weight, their major, the days out of the week that they drink, and the number of drinks that they have when they do drink. So, because these data are variegated, we can actually inspect them in a few different ways. First, we can run a command called names on the object called mydata, because this is what we named the object when we read it in. You notice that we have the arrow here. That's assigning the CSV file that we read in to an object called mydata, which is reflected in the environment. Now if we type names mydata, what it gives us is the column names, which are also the variable names that you'll be working with. If you go back to the object, you'll notice that these correspond: ID, age, height, weight, major, days drink, and number of drinks. Now you can also investigate and look into the data a little bit. With this data set, it's a little inconsequential because we're able to look through all 30 observations. But let's say you have several million. You might want to look at the first 10 to make sure that they're structured properly. If you hit Control-Enter on line 30, you'll see the first 10 observations in the data set called mydata. Now you can also look further into what this data object is and look at the structure. Now what this will do, if you click Control Enter on line 31, is return the kind of data that's stored in each variable within the data frame. As you'll notice, most of these are integers, which are just R's word for number. The major, however, is stored as character vectors. So pol sci, legal, these are all non-numeric values. They can still be worked with, but it's important to understand what your variables are in terms of their structure before you go about analyzing them. Now, if you want to just get an idea of what one variable is, you can type the $ after my data and ID, or the variable name, for example, and you can look at the class of that object. So the class of the ID is integer, much like it's reflected right here. The class of major, alternatively, is characters. Finally, while we were able to view this just by clicking on it, R is completely functional without a mouse. So you can use the function view and my data, and it'll do the exact same thing as when we clicked the object. This allows you to give a more thorough inspection. Now that we've gone through looking at our data object and we've read it in, we can actually start to begin to perform some summary statistics on it. So for example, if we were curious about the mean average age of the respondents in our data set, we could type Control Enter on line 38, and we would get the mean of my data age. The average age is just under 20 years old in this respondents. We can also get the median value, which is different from the mean in both statistical terms, and it also gives you an idea as to the skew of the data set when compared against the mean. So the median is 19.5, not too far off. Now we can also get the average number of days that these students drink out of the week. It's about 4, just under. And we can get the average number of drinks that they have when they do drink, which is close to 6. Now, when you're looking at summary statistics of data, you can also look at them for a subpopulation. So say that we have this hunch that political science students drink more days out of the week than legal studies students, but maybe they drink less when they are drinking. We can test this by using something called a which function. This goes within a bracket after a data frame object. So you'll notice that we have the variable specified here, my data, $days drink. But the bracketing tells R that we're going to be looking at a specific subset of the data frame, namely which variables or which observations have the value of pol sci for their major. And so what this line will do on 45 is give us the average days out of the week that political science students drink. So let's click Control Enter on that. About 3.5 days out of the week for political science students. Legal studies students, conversely, are closer to 4.5. So turns out legal studies students are drinking more often than political science. Again, these data are completely false. We can do this again for the number of drinks when they do drink. And it looks like legal studies students also drink more when they do drink. Now the averages and medians, these are all interesting, but we can also go a little bit further. We can inspect the range of the values in a given observations, or across observations. So let's look at the range of ages in our data set. Again, we're specifying the data frame, my data, $, and then the name of the variable, age. So if we do range, we'll see that it gives us 2 values, the minimum and the maximum. So all students within this data set are between 18 and 22 years old. We can also look at the minimum and maximum number of drinks that students have on the occasion that they do drink. It looks like it's between 0 and 12. Finally, there are other summary statistics beyond range, mean, and median, including the variance and standard deviation of a data set. These are descriptive values that basically show the amplitude of the variance across a distribution. So if it's all centered in around the mean, so if all the ages are centered around 20, the variance will and the standard deviation will be very low. If there are a lot around both 18 and 22, the variance and standard deviation will be high. This is also true of the number of drinks between 0 and 12. So if we look at the variance, it's about 11.74, meaning it's a pretty wide distribution. And the standard deviation, the numbers of steps on either given end of the mean of a distribution, is 3.5. We can go further and try visualizing these data as well. We can visualize the distribution of any of these variables with a histogram. The histogram function requires only that you specify the variable being loaded. In this case, it's my data, $number of drinks. So we're going to look at the distribution of the number of drinks that students have. And then you specify the number of breaks. So you'll notice on line 61, I specified specifically 10 breaks. R also allows you to enter a value quotation mark FD end quotation mark. This is a particular algorithm that determines, based on the number of observations you have, how many bars would be appropriate. Just to quickly pick up where we left off, we're doing some histogram visualizations of different variables observations in our data set. So if you run the histogram on the number of drinks on line 60, we're going to use the FD algorithm to determine the number of breaks that would be appropriate for this histogram. So if we hit Control Enter, you might want to actually move this spread over here by clicking on it and dragging. The plot is going to show up in the bottom right. So hit Control Enter on line 60. You'll get a visualization of the distribution of the number of drinks that students have on average. You can also get the days that these students drink and specify a more specific number of breaks. So you'll see that this one skews a little bit more right. That's fairly representative of college students, I'd imagine. Now we can also run bivariate visualizations. So these would be a scatter plot. In the first one on line 64, we're going to look at the relationship between the height of the respondents and the number of drinks that they have in a given week. The X value is the first one that we enter, my data, $height, and the Y value is the number of drinks, my data, $num_drinks. So let's hit Control Enter on line 64, and what you'll see down here is the distribution of heights on the x-axis between 55 and 75, and then the distribution of the number of drinks between 0 and 12. And any one of these dots represents an observation where we have someone who's close to about 55 inches tall and has about 8 drinks in a given week. Each of these represents one of those observations, and with other commands we can fit a line of best fit to observe a pattern across these. But for now, let's just look at some other scatter plots, including the distribution of weight and the number of drinks. These don't look like they resemble very much of a pattern, but again, completely randomly generated data. Now let's move forward. In R, you can actually assign a value or a set of values to almost any variable. Some variables are off limits because they represent commands, base commands within R, but for the vast majority of letters, you can just assign anything to it. You can even create a word for your variable. So on line 69, we're going to assign the value 2 to the letter V. Now, if you want to assign to a variable, make sure never to put quotation marks around it. When you put quotation marks around characters, it becomes a character string. But let's assign 2 to the letter V. Now, when we try to run the operation V plus 5, it'll logically give us 7. And if we run V over 3, we'll get 0.6 repeating. The number of significant figures spat out by your R or RStudio is dependent largely on your operating system and different specifications, so don't worry if you didn't get the exact same number. Now we can also apply a statistical function to one of our variables, so for example age, and assign that to another variable that we can work with independently of the data set that we have, right? So let's say we want the average age and we want to assign that to a variable called age mean. We'll hit Control Enter on line 74, and you can see in your environment that that pops up with 19.83 repeating. That's the average age in the respondent set. If you want to ever call this variable, you can just type it and enter, right? Age mean. You can even type it down here in the console. It may even suggest it for you. Hit enter, and it'll give you the value. Now we can do this with the average days of drinks, and with the number of drinks, or with any of the variables that we have. Now finally, you can also create a new column in your data frame based on an interaction of the variables within it. So let's say that we're interested in the number of drinks that students have on a week based on their average estimates that they provide. So what this would involve is multiplying the number of days that any given student drinks by the number of drinks they have on that day. So what we'll do is create a new variable called week drink, and we'll assign that to my data $week drink. Again, assigning includes the less than sign and the hyphen. That's how we assign all of this to the variable to the left. So let's just quickly enter this, and then we can call that by just typing in my data $week drink, and it'll give us the interaction for each of the observations with regards to the number of drinks and the days that they drink. We can get the average of this value, about 24.8 drinks in a week. We can get the distribution with our histogram command. Again, that'll show up in the bottom right. And we can even compare this, plot this alongside height to see if there's some kind of a relationship. Looks like we might have an even stronger one in this one. Furthermore, you can sample random numbers with R. That's actually one of the strongest things that it's able to do. So let's say that we want to assign to a variable called ransamp a sample of numbers between 1 and 1,000, but we only want 100 of them. So we'll use the command sample, and the parameters for this command include x, which is the values from which we're sampling, between 1 and 1,000 here. The size, which is exactly 100. We only want 100 of the values between 1 and 1,000. And whether you want to replace when you sample. Now this is important. If this is true, when R samples the number, it'll put it back to be possibly sampled again. So if we were to sample the number 596 and replace equals true, we could get the number 596 in our dataset again. So I'm putting false here so that we only get unique values between 1 and 1,000 for the 100 values that we're sampling. So let's quickly look at that. We can highlight it and click enter. If you highlight one of the lines in your script and click control enter, it'll only run that. And you'll see that we have 100 values between 1 and 1,000 here. We can even get the average by calling our mean function, and we'll notice that it's actually very close to the average of 1 and 1,000. Now let's get forward and make our own data set with random sampling. I'll let you in on a secret. The data set we've been working with has been completely randomly sampled. So these are all fake values that I used R to generate. So we'll just, again, quickly get the names of the data set that we're working with so that we can sample a data set for each of these and assemble our own data frame. Next, we're going to set a seed. This is on line 97. When you set a seed, you basically tell R where to start when it's looking for any given set of random numbers. This is so that you can replicate your work, or others can replicate your work if it involves random sampling. It's very important to include a seed if you're doing any kind of a serious project that involves random sampling. The number doesn't matter at all. 328 is in here just for fun. You can put any number that you'd like in there, but it's very important to remember to set this. Otherwise, you may get slightly different results, and someone who might try to replicate your work would get different results and may question the validity. So let's quickly set the seed to 328 on line 97. And what we're doing between lines 101 and 106 is creating new variables for each of the names that we saw, right? So we're going to get IDs for our data set. We're going to get about 100 randomly sampled values for observations, we'll call them. So IDs are going to be 1 to 100. And you'll notice I just use 1:100 here, and that gives me all of the values between that. And you can see that up here in the environment. For ages, we're going to sample between the values 18 and 30, and we're going to get 100, right? So that we have the exact same number of ages as we have IDs, heights, weights, majors, days, and number of drinks. So we'll sample between 18 and 30 for ages, and now we have a data set of ages, 27, 28, 22, 30, different things like that. The same will go for heights. You'll notice that we have that up here. Weights, again, we've got that up here now. Majors, we're introducing a new one, sociology. And you'll notice that with majors, you can actually sample from a character vector. So up here where we're sampling between numbers, 100 to 250, we're actually going to sample across a set of characters, vectors here. Now we want replace to be true for all of these, because in some cases, it's impossible to get 100 unique values from, say, a set of 3 or a set of 12. The alternative reason that we want replace to be true is that we don't necessarily want exactly distinct values. Sometimes it's likely that two people may share the same height or major. So let's quickly sample that, and you'll notice that the majors is just a bunch of different pol sci, sociology, and legal studies. For days, we're going to sample between the days of the week that people drink. And for drinks, we're going to sample a conservative estimate, I hope, of between 1 and 12 drinks that someone would have on any given night. Now between lines 109 and 115, we're using a command called dataframe. Now with this command, you're going to enter the name of the variable that you want the data frame to have. So I want to create a variable called ID with capital I, capital D. We're going to use the equal sign, and then we're going to assign our new variable of IDs to that. That's going to be the numbers 1 through 100. The same goes for age. We're going to assign our new ages data that we just sampled between 18 and 30, as well as heights for height, weights for weight, majors for major, days for days drink, and drinks for num drinks. Now let's quickly click Control Enter on all of that. And you'll notice you have a new data set up here called My New Data. It has 100 observations of 7 different variables. We can quickly click on that, and we'll notice that we have a very similar data set to what we originally read in, and it was made entirely within our R session. Now, when we did this, we actually introduced some logical inconsistencies into the data set. Specifically, if someone doesn't drink any days out of the week, the number of drinks that they have in a given week should be 0. Because we sampled between 1 and 12, there are going to be some cases where people have 0 for their days, but more than 0 for their drinks. So we're going to use that which function that we used earlier to specify a subpop. Sorry again for that, folks. We're going to get quickly back to this. We're right at the end here. We're creating, we're addressing logical inconsistencies in the data set. Basically, we're assigning the value of 0 for the number drinks column in any rows where the day's drink value is 0. So my new data, $num drinks, which my new data solid $days drinks equal 0. It's important to keep both of those there because that's a logical test. We're going to assign the value 0 to that. Okay? Now you notice we can actually highlight this and check it out, and they'll all be 0. It looks like we've only got a few of those instances. So we're going to conclude here by trying to get our working directory, which if you were successful in setting your working directory at the beginning of this, should just be your desktop folder, my working directory. For me, we didn't do that, and it looks like it's my documents. Now we're going to run a final command here called write.csv. This will take any data frame, particularly your new my_new_data data frame that we just created, and it'll write it out within the working directory that you've specified, or within the path directory that you specify in the name. Because we're just using a CSV name and not any backslashes to specify a path file directory that goes into any subfolders, this will write the mynewdata.csv, which contains the mynewdata data frame. And in my case, it'll write it into the documents folder. In your case, it'll write it into whatever folder was spat out when you typed in getwd, Control Enter. Finally, there's a parameter called row names. We're specifying this to false because if you write this out, it'll give you a column in front of all of the rest of the data with the row names of your data set. You'll notice if we type row names, my new data, it actually has a great number of row names. It's the numbers 1 to 100, but they're characters because it's the names of the rows. Because we already have a variable, ID, row names are actually superfluous, and it'll sometimes be annoying to get an extra column like that. So we're going to say row names equals false so that it doesn't write those out. And if you click Control Enter on line 123, you will now have the mynewdata dataset that we generated in a CSV file titled mynewdata in the working directory that you just found. You can go into that folder, try and find it, open it up. You'll notice that it works just like any other Excel file, and it contains all of the data that we just generated. I hope that this was informative for you folks. I understand that some of you already have existing R knowledge, and I apologize if some of this was superfluous. But for those of you who are new to this, I hope that this gave you an excellent introduction or crash course into R. Feel free to email me anytime you need. My email address is temarple@gmail.com. I'm happy to help you out with any of your data projects, and Stephanie Chan is also happy with any research or data questions as well. So feel free to reach out, and if you don't need any help, have lots of fun analyzing your new data. Thanks, everyone.